Hi students, today we are going to learn about the composite of functions. The objectives of this lesson are 1. Notation f round g, 2. Expression of f round g and g round f, 3. Domain of definition of f round g, 4. Derivative of f round g. We start with the composite of two functions. The composite of two functions is denoted by f round g and g round f. F is a mapping that associates to every value of x an image f of x, and g is a function that associates to every x an image g of x. G round f, x is an antecedent with respect to f, and f of x is the image of x by f. G of f of x is the image of f of x by g. The function f round g. X is an antecedent of g, and g of x is an image of x by g. F of g of x is the image of g of x by f. 2. Expression of g round f and f round g. F round g round f of x equal g of f of x, and f round g of x equal f of g of x. Let f of x equal x power 2 and g of x equal radical x minus 2. Determine the expression of f round g and g round f. G round f of x is equal to g of f of x. Then we replace in g x by f of x. Since g equal radical x minus 2, then g of f equal radical, replace x by f of x. So it's radical f of x, radical f of x minus 2, and f of x equal x power 2, then it's equal to radical x power 2 minus 2. But f round g of x equal f of g of x, but f is equal to x power 2, f of g, replace x by g of x. So it's equal to g of x power 2, and it's equal, substitute g by its value radical x minus 2, so it's radical x minus 2 power 2, and it's equal to x power 2. Then we noticed that g round f of x, it's not equal to g round f. 3. Domain of definitions of f round g and g round f. G round f is defined for, since x is an antecedent of f and f of x is an antecedent of g, so x belongs to the domain of f and f of x belongs to the domain of g. Since g round f of x, g round f of x is equal to g of f of x, x substituted in f, then x belongs to domain of f, and f of x is antecedent of g, g of f of x, then f of x belongs to the domain of g. Let f of x equal 1 over x minus 2 and g of x equal radical x minus 4. To determine the domain of definition of f round g. F round g is defined for x belong to the domain of g and g of x belong to the domain of f. X belong to domain of g. Since g of x is radical x minus 4, so x minus 4 should be greater or equal to 0, then x greater or equal to 4. That's it. And g of x belongs to the domain of f. Domain of f is defined for all values of x except 2. So g of x should be not equal to 2. And g of x is radical x minus 4, so x minus 4. So radical x minus 4 not equal to 2. Squaring both sides, then x not equal to 8. So its domain of definition is x greater than 4 and x not equal to 8, then x belong to 4, 8 union 8 plus infinity. Since x greater than 4 but x not equal to 8. 4. Derivatives. Derivative of g round f. Derivative of g round f of x is equal to g prime of f of x times f prime of x. But f round g prime of x equal to f prime of g of x times g prime of x. If f of x is equal to 1 over x minus 2 and g of x equal to radical x minus 4, to determine the derivative of g round f, as you see above, g round f prime of x is equal to g prime of f times f prime of x. So we determine f prime of x and g prime of x to determine g prime of f of x. When you determine g prime of x, then replace x by f of x in the g prime, so you determine g prime of f of x. First, we find f prime of x. F is in the form u over v. U prime, so f prime equal to u prime v minus v prime u over v squared. U prime is 0 times v, 0 minus v prime 1 times 1, so it's minus 1 over v power 2, so it's x minus 2 power 2. And g prime is equal to radical x minus 4, so it's in the form of radical u, and the derivative of radical u is u prime over 2 radical u. But if g equal radical x minus 4, so u is x minus 4. If u equal x minus 4, then u prime equal 1. And g prime equal u prime over 2 radical u. U prime is 1 over 2 radical u, and u is x minus 4. Then g round f prime of x equal g prime of f times f prime. F prime, it's minus 1 over x minus 2 power 2. But the g prime of f of x, we determine g prime of x, but here g prime of f of x, then we replace x by f of x in g prime, and hence it 1 over 2 radical f of x minus 4 times f prime. Then we substitute f of x by its value 1 over radical x minus 2. Then we get g round f prime of x.